Welcome back there, class. Mrs. Matheson here. We're going to be talking about Unit 1, Notes 5, and writing inequalities. Our learning target today is I can write and graph linear inequalities. So once we can write it, we can graph it. So let's get right into it. First, let's remind ourselves of some of our inequality symbols. So if we see not as much as, fewer than, less than, we're thinking the less than symbol. If we're seeing greater than, we're going to want to look for words that might say more than. Less than or equal to, we're looking for at most, no more than, and then last, greater than or equal to, we're going to look at no less than and at least. All right, so Hannah budgets $30 a month for lunch. On most days, she brings her lunch. She can also buy lunch at the cafeteria or at a fast food restaurant. She spends on average $3 for lunch at the cafeteria and an average of $6 for lunch at the restaurant. How many times a month can Hannah buy her lunch and remain within her budget? So we have two unknowns here. We have the unknown of buying lunch at the cafeteria, and we have the unknown of buying lunch at the fast food restaurant. So we're going to designate X to be the number of days she buys lunch at the cafeteria, and we're going to designate Y to be the number of days she buys lunch at the restaurant. So make sure that you write that down so we know what we're referring to. So we spend $3 per lunch at the cafeteria, so we're going to say that is 3x. Plus, that during that month, we are going to spend $6 per lunch that we buy at the restaurant. But we have only $30 a month for lunches. Or so we're thinking, can we spend less than $30? Well, yeah. Can we spend exactly $30? Yep. Can we spend more than $30? No. So we're going to have a less than or equal to sign. All right, so this is going to be our inequality here. Oh, let's move that all together and give us a little bit more space. So we're thinking about that's in standard form, but we can't graph in standard form, so we need to convert this over to slope-intercept. We're going to minus the 3x to both sides, and we get 6y is less than or equal to 3x. I know is not a like term with 30, so I'm going to write them as separate. So negative 3x, 30 is positive, so it becomes plus. Then I need to get my y by itself. So I'm going to divide both sides by 6. Now remember, you're dividing each individual piece by 6. We get y is less than or equal to, my inequality symbol did not change. We didn't divide by a negative. Negative 3 divided by 6, or negative 3 over 6, we want to know, is reduces to negative 1/2 x. And then 30 divided by 6 is 5. So here we wrote our inequality. Great. But now we need to graph that inequality. So we have a graph here, and let's label our axes. So our x we talked about is when we're at the cafeteria, and our y is when we're at a restaurant. Okay, so my y-intercept is 5. I'm going to go up 5 and make a point. And my slope is negative 1 over 2. So I'm thinking that this is rise over run. My rise is negative 1, so I'm going to go down 1, and my run is 2. And so I want to pay attention to my graph and see what it goes by on its line. So I know I can go down 1 and over 2 lines, down 1 and over 2 lines, down 1 and over 2 lines, and down 1 and over 2 lines. So we're going to graph this, but now we need to decide, is that line solid or dotted? Well, it's got the equal to, so this is going to be a solid line. And shading. We need to shade this because it's inequality. Well, remember that when y is less than or equal to, we're going to shade down. If you don't remember those things about solid and dotted and shading up and shading down, go back to your Unit 1 Notes 5 and jot those down onto this sheet. And that's all we have to do for this problem. So let's go ahead and look here. Rosa sells radio advertising in 30-second and 60-second time slots. During every hour, there are up to 15 minutes available for commercials. How many commercial slots can she sell for 1 hour of broadcasting? All right, well, they even tell us that X is going to be the number of 30-second commercials, and Y is going to be the number of 60-second commercials. I'm looking at that. Okay, great. So I'm going to take 30 times X because 30 seconds times every 30-second commercial. Plus there are 60-second commercials, so 60 times Y because that's how many not 60-second equations or commercials there are, but I need to think about it. If it's a commercial, now can they go less than the 15 minutes? Well, yeah. Can they go equal to the 15 minutes? Well, yeah, because you have up to 15 minutes. And can we go more than 15 minutes? So we can't go more than 15 minutes. So this is going to be a less than or equal to 15. Wait. Something's going to be funny here. I've got 30-second commercials and 60-second commercials and 15 minutes, seconds. This is seconds. This is seconds. This is minutes. I don't like that. I hope that this is bringing a red flag to you and you're going, whoa, don't like it, don't like it, don't like it. We want this to be in seconds also. So we need to take 15 times 60. Go ahead and do that on your calculator. 15 times 60 is 900. There are 900 seconds in 15 minutes. Now we're dealing with seconds, seconds, and seconds. So let's go ahead and solve for our y so that we are in slope-intercept form. We are going to start off by moving our x term. So subtract 30x to both sides. So we have 60y is less than or equal to 930x are not like terms, so my negative 30x comes first, plus my 900. We want to get y by itself, so it's 60 times y, so I'm going to divide by 60. Remember, we're dividing each individual term by 60. So y is less than or equal to negative 30 divided by 60. Well, that's going to reduce to negative 1/2 x. 900 divided by 60, that's going to give us 15. There's our equation. So now we're going to go ahead and graph it. So I noticed that my axes aren't labeled, so we're going to do that. And let's do, we said x is 30 seconds and y is 60 seconds. So my y-intercept is 15. So I go all the way up to 15 and I make my point. My slope is negative 1 over 2. Each of my lines are going to be worth 1, so I can go down 1 and over 2 and continue to do that all the way until I go off my graph. Now, you always want to make sure that we go completely through the graph. Okay, so is this a solid or a dotted line? Well, it's got that equal to, so it's going to be a solid line. Okay, and it's also a less than symbol, so we can shade down. All right, great job, guys. Lee Cooper writes and edits short articles for a local newspaper. It takes her about an hour to write an article and about a half an hour to edit an article. If Lee works up to 8 hours in a day, how many articles can she write in one day? All right, she's working up to 8 hours. So again, that's going to be our less than or equal to. Ooh, we have writing and we have editing. So let's call X writing and let's call Y editing. Okay, so it takes 1 hour to write an article, so 1 times X, plus half an hour to edit it. Okay, guys, so I want you to convert this into slope-intercept, so we have our Y and our MX supposed to be on the other side, and I want you to graph it. Then we have the next problem on the top of the back of the worksheet. I'm very confident that you guys are going to be able to come up with this because it already tells you that our pizzas are X and our pops are Y. So you have those two problems, problem 3 and problem 4 to finish for tomorrow. And I can't wait to discuss 5 and 6 with you guys. See you then.